Good evening and welcome to the Marion Minor Cook Athenaeum. My name is Sarah Sandbar and I'm one of the fellows here. To many people, myself included, the field of mathematics seems complex, separated from the concerns of daily life and borderline incomprehensible. Chinese officials from the 1960s and 70s would have agreed with me. During the time of the Cultural Revolution, mathematics was under scrutiny and suspicion for being too aloof from the concerns of common men and essentially useless in an agrarian society. Yet the discovery and translation of the mathematical manuscripts of Karl Marx brought in a fresh new approach to the field of abstract mathematics, this time a Marxist one. Joining us tonight to explain the union of Marx, Mao, and the politics of infinitesimals is Professor Joseph Dauben, a distinguished professor of history and history of science at the City University of New York. He is the author of biographies of George Cantor and Abraham Robinson, and most recently, a 3-volume Chinese-English dual-language edition of the ancient Chinese classic, the 9 chapters on the art of mathematics. He is an honorary member of the Institute for History of Natural Science of the Chinese Academy of Sciences, and in January of 2012, he received the American Mathematical Society's Albert Leon Whiteman Memorial Prize. He is also a CMC alum. As always, I must remind you that audio and visual recording is strictly prohibited. Please join me in welcoming Professor Joseph Dauben.
And if we were in a New York theater at this point, they would also remind you after telling you, please not to record any of this material, which is fine with me. Please turn off your cell phones. I remind my students of this all the time, but they don't seem to pay any attention. It's okay with me. I'm used to talking through ringing things and crying babies and all sorts of things, so it's perfectly okay. I want to thank Sarah for that very kind introduction, and I want to thank Michael, her cohort as an Athenaeum Fellow, for having arranged the conversation at our table so flawlessly. I've had a wonderful chance to meet students from CMC, the current breed of CMC students, and when I was here in 1966, I can tell you it was a very different campus. The students were quite different, the atmosphere was quite different, and it's really a pleasure to be here this evening. Just a year short of my 50th anniversary, which was celebrated last spring actually, and I couldn't make it to that meeting because I was in Beijing. But I'll get to all of that in a moment. I also want to thank, at the outset, Professor Asuman Aksoy of the Department of Mathematics, because it was really Professor Aksoy, thanks to a meeting that I attended here just about a year ago, that she thought it might be interesting if I were to come to the Athenaeum and give a talk of the sort I'm going to give this evening. So I'm very grateful to her for having set the wheels in motion that made this evening possible. And then I want to thank Priya Jumar, whose role as the director of the Athenaeum has really made all of this go like clockwork. I really appreciate everything she has done logistically to make my coming here and the time I've already spent here a wonderful reminiscence of coming back to CMC in the best of times that I can remember when I was a student here. So thanks very much to both of them. As you've already heard, I'm an alumnus of Claremont Men's College. Slightly different name, but the logo at least didn't have to change when the name itself changed. And I was here from 1962 to 1966. That's how I looked when they took my yearbook photo in 1966. I know it bears no resemblance now, but that's what it looked like 50 years ago. And then in 1976, the college changed its name to Claremont McKenna College. And I was very happy as we were getting ready to celebrate the 50th anniversary of my own class last year, that I was reminded more than once that Claremont is now considered one of the nation's top 10 happiest colleges in the country. And coming back, I can see why. Not only is it a visually stunning campus, it wasn't bad looking then, but it's really extraordinary, the campus as it's developed over the years. But the weather, of course, remains extraordinary. And as the Princeton Review put it, phenomenal academics, perfect weather, brilliant professors, as one student said, When you take both academics and quality of life into account, I can't believe I almost went to an Ivy over this place. As an alum, it's wonderful to hear that. Among other activities while I was at CMC, I was a part of the debate team for 4 years. And in my senior year, in 1965, I was elected student body president. And this made it possible for me to get involved with the government and the politics across all of the then 5 campuses at Claremont. Pitzer was just beginning to come online, and it was a real pleasure to have that opportunity to work with the fledgling student government at Pitzer. And I think that the Claremont yearbook was right in 1965, the year before I graduated, when it dedicated the yearbook to the student body at Pitzer College. You can't imagine what a difference it made for the men at CMC, Claremont Men's College, in those days. And then the other reason I'm here this evening is because of my good friend, colleague, and former tutor at Harvard, Judith Grabner. It was last year, just about this same time, almost a year ago to the day, that I was here celebrating her retirement from an extraordinary career at Pitzer as the Sanborn Professor of Mathematics. And I want to thank you, Judy, not only for having gotten me started as an historian of mathematics when I was at Harvard many, many years ago, but for letting me come back to the celebration of your career here at the Claremont Colleges. And it was a wonderful opportunity to have done so. Here's the math department as I recall it when I was here at Claremont. The chairman then was John Furling, 1966. This is his yearbook picture. And if you remember the yearbooks then, I don't know what they're like now, but one of the prerogatives of the CMC yearbook editorial committee was to pick little quips that would go with the pictures of the professors that they would take each year. So I'll let you guess. What do you suppose is the one that accompanies Professor Furling here? Fresh paint. The second person in the math department that had a tremendous influence in my career was Professor Granville C. Henry. And here's Professor Henry at the blackboard. The first course I ever took in the history of mathematics was with Professor Henry here at CMC. And here he's explaining the Greek word logos. This is the Greek word for word, but in mathematics it has a very technical significance. It refers to that which is rational or thinkable. And it was the Pythagoreans who discovered that there was something that was in fact not thinkable, not speakable, that you could not name. You could not give it a ratio. It was the incommensurability of the side to the diagonal of the square. Our word irrational is connected to all of this. That's what Granville is explaining here. And you can imagine what the little quip under this picture is in the yearbook. You pronounce it yo-yo, so he got that right. And then the last person at CMC in the math department who had an equally important influence on my future career, although neither Professor Janet Myrie nor I really appreciated it, I think, at the time, was the role that she played in advising my senior thesis. I wrote an honors thesis here in mathematics. It was on nonstandard analysis. And I took the approach that a colleague of hers at Caltech took, Wim Luxemburg, who approached nonstandard analysis in a very different way from that in which it was originally conceived, through the very technical machinery of mathematical logic. Mathematicians aren't very happy with mathematical logic in many respects, and so Wim Luxemburg converted that theory into one that was very convenient for people to apply in analysis and other branches of mathematics. And that was the approach that I took, thanks to Janet Myrie's direction. You can guess maybe, well, you possibly guess what the quip under this is. Any of you who are mathematicians, though, will appreciate the succinctness and the value of having a one-line proof. Well, I then in 1966 went to Harvard, and I got to Harvard and into the history of mathematics in a rather circuitous and strange way, but as I was telling the students at the table this evening earlier, the best things that can happen to you in life are the ones that are completely unscripted, the ones that you don't really prepare for. I'd taken a course in the history of mathematics with Granville Henry. I'd written an honors seminar paper with him that last spring of my senior year here. It was a seminar devoted that year to science and religion. I'd become interested in Alfred North Whitehead. Some of you may know that Whitehead used mathematics to develop his process philosophy. And I knew that Whitehead had finished his career at Harvard. So I applied to Harvard in philosophy. I applied at Princeton and USC in mathematics, and to Stanford in English literature, because I had a double major and I didn't know what I wanted to do. Well, the upshot of it was, remember I was on the debate team and we had managed to win a series of debates, and I wound up at Harvard in late January of 1966. I thought, well, I should go into the philosophy department and tell them I'm here and see if they've got my application and what they think. The philosophy department at Harvard was, as then and is today, in Emerson Hall. I went upstairs, and who should be sitting there but Van Quine and Hilary Putnam, two of the great philosophers at Harvard. I introduced myself, and they said, oh yeah, you're that Whitehead guy. You don't seem to understand. We don't do that anymore. That's history. Why don't you go see the people over in history of science? I said, history of science, what's that? Well, they explained to me that it was a new department that had just been formed at Harvard where you could get a PhD in the history of science. Who knew? So I walked over and I explained to the people there, I, Bernard Cohen, John Murdoch, two of the great figures in the history of science in this country. And they, having listened to what I'd said about my work as a mathematician here at CMC in my senior thesis and everything, they said, well, if everything you tell us is true, just go to Holyoke Center, the administrative center of Harvard at those days, and just tell them to switch your application from philosophy to history of science, which I did. To make a long story short, I wound up at Harvard. And it was one of those things I had not prepared for, but I got there, and within 2 years, as I got to Harvard, if you'd asked me the difference between Newton's optics and his Principia, I couldn't have told you. But within 2 years, I realized I had found a field that was fascinating, and it was exactly what I wanted to do. And so, at Harvard, I was prepared for my oral examinations in the history of mathematics by Professor Judith Grabner. She had just finished her PhD at Harvard, and I think was the senior tutor then. And she took two historians of mathematics, hopefully, under her wing, Wilbur Knorr, my colleague on the left, who had been a Harvard undergraduate in history and science, and I was there to do my PhD in history of science, and we did. I was also mentored by three extraordinary professors at Harvard and one MIT. On the left is Dirk Stroek. He lived to be 106, an extraordinary historian of mathematics, very interested in Marxism in the history of mathematics, something I've later come to appreciate more than I did at the time I was writing my thesis with him on Georg Cantor and the development of transfinite set theory. Erwin Hebert, an historian of German physics, who at Harvard on the faculty in the history of science was really the person closest to what I was doing in German history in the 19th century. And then on the far right, Richard Brouwer, the great algebraist, who had actually lived in Berlin, came from Germany, knew many of the people who had known Georg Cantor about whom I was writing. So he was a real touchstone. When I was writing about Georg Cantor, he was happy to read what I was writing, said, that doesn't sound like the Berlin I remember. And this was very helpful to me to have these three people. Really, having been trained by Judith Grabner and then working with these people, I couldn't have gotten off to a better start as an historian of science. My first book grew out of my thesis, a controversial subject, as I'll have a bit more to say in a colloquium lecture I'm giving tomorrow about the attempt to win the battle for transfinite set theory, but this is how that battle is sometimes portrayed. This is a caricature out of a French periodical. My second book was about Abraham Robinson and the creation of nonstandard analysis, about which I'll be saying a bit more this evening. Nonstandard analysis, you could say, is the inverse of the first book I had written, because Cantor's theory was about the absolute infinite, and nonstandard analysis about how you can develop a rigorous theory of the infinitesimal, the very small in mathematics. For centuries, people thought that was not possible. Even Georg Cantor thought that the concept of the infinitesimal was logically paradoxical. It would involve you in contradictions. But Robinson found a way, using mathematical logic, to prove that that was not so, and rehabilitated, you might say, the infinitesimal, used really in a very informal way by Newton and Leibniz, but now made rigorously and academically acceptable by the work of Abraham Robinson. And then in 1987, my life took another one of those 180-degree turns. I was invited by the National Academy of Sciences to spend 6 months in China, just talking about history of science, any place that I might be interested in going or that people might be interested in having me come. Who could say no to that? I'd spent almost 25 years in Europe working on the history of mathematics there. A lot of the time I'd spent in Italy, for reasons I won't go into now, but Italy had joined the European Economic Community. The lira was gone. The euro was being used everywhere. People were speaking more and more English. There was a McDonald's or a Guinness pub on virtually every corner in Rome. And I got to Beijing, and it was different. It was exotic. It was something I had never seen before. And it was thanks to this gentleman, Professor He Jiawu, a prominent intellectual historian at Tsinghua University in Beijing, who had basically made this invitation possible. Through the Chinese Academy of Sciences and the US Academy, they jointly sponsored this exchange. I got to Tsinghua University. He said, well, I'm so glad. The good news is you're here in China. The bad news is you won't be at Tsinghua. Tsinghua had 5 American professors on this exchange that year, and he said 5 is too many for Tsinghua. So we're putting you with the Institute for the History of Natural Sciences, which is where I should have been all along. I was staying in this little courtyard, Bingguan, a little guest house on an old hutong in Beijing. This was the director of the Institute then, Xi Zizong. He's an expert on the history of ancient Chinese astronomy. The deputy director of the Institute then was Li Peishan. You can tell by what they're wearing. The Cultural Revolution was still not completely forgotten. The Institute still had weekly indoctrination meetings, but I didn't have to go. And these were the historians of mathematics at the Institute. Du Shiran at the top, Guo Shuchun, with whom I've collaborated in working on a new edition, a new collation of the 9 chapters of ancient Chinese mathematics. This is sometimes called the Euclid of ancient China. And then Liu Dun, the later director of the Institute for History of Natural Sciences in Beijing, himself an historian of mathematics. As he once said to me, Joe, really the only difference between you and me is that I spent 10 years in Inner Mongolia as a cowboy during the Cultural Revolution. But these were 3 extraordinarily well-trained and talented mathematicians who had turned their interest to history of mathematics, and they became my teachers. I could not have had a better group of people to teach me the history of Chinese mathematics than these 3 people in Beijing. And then this last man is Professor Li Di. He created the Institute for the History of Mathematics and Science at Inner Mongolia Normal University in Hulahat in Inner Mongolia. And I also had the privilege of visiting and working with him in Inner Mongolia University. And that, in a nutshell, is what brings me to tonight's topic. Marx, Mao, and mathematics. And as the students at the table earlier were saying to me, how could you possibly put these 3 things together? And that's what, in the course of the next half an hour or so, I'm going to try and tell you. It all begins, in a way, with this woman, Sophia Alexandrovna Yanovskaya. And Yanovskaya was trained at the University of Moscow, and in 1933, she undertook a study of the mathematical manuscripts of Karl Marx. Now, the mathematical manuscripts of Karl Marx were first mentioned actually by Friedrich Engels, who called attention to the existence of these manuscripts in the preface to his famous work, Anti-Dühring, in 1885. A more definitive edition, however, of the mathematical manuscripts was published under the direction of Yanovskaya in 1968. And subsequently, numerous translations have appeared, including 2 in Chinese. The reasons why there are 2 I'll get into a little bit later, but here's the front page of the Chinese edition. And the question of the infinite in the history of mathematics, I'll just tell you something very quickly and briefly about this, goes back literally to antiquity itself. And this is the frontispiece, the first page of the opera omnia, you could say, of David Gregory's version of Euclid's Elements. And it has a frontispiece by the Oxford engraver, Michael Burgers. He has a very interesting history as well as an engraver. But this is the frontispiece, and it represents the shipwreck of a Socratic philosopher, Aristippus, washed ashore with fellow shipmates, who points to geometric diagrams that he sees in the sand and exclaims, "I see a vestige of man." Now, this shipwreck is reminiscent of another less fortunate incident at sea, the death of the famed Pythagorean mathematician Hippasus. One of the basic tenets of Pythagoreanism, the concepts of harmony and commensurability, that all things could be measured by numbers, were greatly upset by the discovery that the side and the diagonal of the square were incommensurable. I mentioned that before. This discovery of incommensurability, or the irrational, was of such momentous import to the Pythagoreans that they insisted it be kept a well-kept secret. And yet, one of their members presumably divulged that secret, and as a result was said to have died at sea as punishment for having let the secret out. No less controversial, and this, of course, is a scholium that can be found to Book 10 of Euclid, which tells you exactly what happened when this mystery of the irrationals was made public. The guilty man was literally forced to be beaten forever on the waves and the rocks, and that's a fate that no one should really look forward to. Hardly better, you could say, maybe was the outcome of another great controversy between two notable mathematicians, again over the problem of the infinite in mathematics, and this involves the creators of the calculus and the priority dispute over who should be given that title, the creator of the calculus. In the 17th century, Isaac Newton and Gottfried Wilhelm Leibniz were the great rivals, philosophers at war, as the historian A. Rupert Hall has put their confrontation. The debate was ideological over infinitesimals and their rather ambiguous status as both zero and not zero. This led to criticism from Bishop Barclay, who called them the ghosts of departed quantities, or Nuentidit on the continent, who raised similar objections to what Leibniz had done. But there were also political implications to this difference between Newton and Leibniz, because Leibniz was the official historian to the Hanoverians. With the Hanoverian succession, the British were fearful that Leibniz might come to England and actually usurp the position that was rightfully Newton's. And so all of this went into the dispute between the two of them, culminating in Leibniz's asking the Royal Society to please appoint a committee to finally make it clear that these were independent discoveries. And this resulted in a report from the Royal Society, and the Royal Society decided that, well, in fact, Leibniz does seem to have copied all this from Newton. What they didn't tell you is that Newton wrote the report. So it wasn't exactly an unbiased decision that came out of the Royal Society by any means. And the last great conflict over the infinite that I'll just mention very briefly, as I said, I'm going to be talking about this a little more tomorrow, is the battle that was waged between Leopold Kronecker, the great mathematician in Berlin. He was a member of the Academy, a professor at the university, and Georg Cantor, the creator of transfinite set theory, who spent his career at the University of Halle in Germany. And they became embroiled in a famous dispute over the infinite and what the correct foundations for mathematics should be, and I won't say more about that. But let's just say the infinite has long been a controversial subject in the history of mathematics. And when we get to Marx and to Engels and their views on mathematics, we'll find that things really haven't much changed. Now, Marx wrote his dissertation at Jena on the Greek atomists, and he was particularly interested in the differences between Epicurus and Democritus, and he preferred Epicurus actually because, as Marx said, he gave a social content to his atomism. But in 1858, preparing for Das Kapital, Marx began a serious study of mathematics, and Engels began a serious study of physics and the other natural sciences. Both were then convinced that without a solid foundation and knowledge of the natural sciences, their analysis of society would be severely handicapped. As Marx wrote in a draft of his 1863 version of Das Kapital, natural science is the foundation of all knowledge. Now, as if the interest of Marx weren't enough that he showed in mathematics, Dirk Stroek, the person I studied with at Harvard, explains that in the dialectical interplay of the finite and the infinite, both of these intrigued Marx and Engels equally. Unfortunately, Marx seems to have limited his reading about the calculus to textbooks that he was able to find in the British Library in London. And this meant that he was drawing upon 17th and 18th century accounts. He seems never to have read Cauchy, for example. And so his ideas about the calculus, let's say, were a little out of date. Now, Engels was also interested in the calculus, but he doubted that its foundations were really on solid grounds. And as he said in a famous polemic that he wrote against Dühring, this is Eugen Dühring, most people differentiate and integrate not because they understand what they're doing, but from pure faith, because up till now it has always come out right. Well, he also went on, perhaps a little too poetically, that the introduction of variables and their extension to infinitesimals and the infinitely large was really the problem, and that this was in fact when the original sin was committed, whereby the otherwise so pure mathematics had eaten of the apple of knowledge, which opened the great way to success, but also to errors. The original condition of the absolute validity, the irrefutable provability of all things mathematical were long past, and the reign of controversies had broken out. This because of the calculus and the acceptance of a mathematical theory on foundations that weren't really quite solid. Now, Marx looked a little deeper than Engels did and saw that the idea of variable magnitudes was directly related to dialectical processes in nature itself. And in 1881, Marx wrote up treatments of both the derivatives and the integrals, which he sent to Engels. And this was all tied into Hegelian philosophy, thesis, antithesis, synthesis. The negation of the negation, 0 over 0, was seen in exactly this context. And that was how Marx and Engels approached mathematics in their work on political economy and the whole problem that Marx laid out in Das Kapital. Now fast forward to the question of 1917, the Bolshevik Revolution. Suddenly, the Soviet authorities have become interested in Marx in a serious way. They've decided they should collect together all of his manuscripts that are possible, including the mathematical ones. And so negotiations throughout the 1920s brought photocopies, literally of everything they could find that Marx had written, to Moscow. And a special study group was in fact assembled. It was headed by Yanovskaya, and she began to study in detail with this study group the mathematical papers of Karl Marx. Now, the first report of Marx's work was actually made by Ernst Coleman. Ernst Coleman is a very interesting figure. He was Jewish from Czechoslovakia. During the war, he was captured by the Russians. He eventually converted to communism, and he went to the University of Moscow, where he studied mathematics, and eventually, in fact, became a party member. And in 1930, when the president of the Russian Mathematical Society, Dmitry Egorov, was arrested by the KGB, the secret police, who should be made president of the Academy of Mathematics, the Institute of Mathematics, but Coleman. And it was Coleman who, in 1931, went to this famous meeting in London, the Crossroads meeting, and announced the work they were doing on the mathematical manuscripts of Karl Marx. And then in 1932, he gave a similar lecture at the International Congress of Mathematicians that was held that year in Zurich. So, work is going on in Moscow to produce the mathematical manuscripts of Karl Marx. This is eventually published in a definitive edition in 1968. And that's where things stand in the West. Meanwhile, in China, and let me just quickly remind you of what's happening in China under Mao Zedong, because this sets the background for which the interest that Mao later has in mathematics will become understandable. Mao was born in southern China, in Hunan province, in December of 1893. At 18 years of age, he goes to Changsha, the provincial capital, where he enters middle school in 1911. He joins the Revolutionary Army, takes part in the overthrow of the Qing dynasty, but then he goes back to his local village. He spends some time in the local library. He passes the examinations and is able to go to Changsha Teachers College. He graduates from there at age 24, eventually gets to Beijing. He becomes a librarian at Beijing University. And then in 1919, he goes back to Changsha. He becomes the principal of a school there. He becomes the secretary of the local Communist Party. The Chinese Communist Party is organized in 1921. Mao's then in Shanghai. In 1923, he's elected to the party's Central Committee. Illness forces him to go home, and it's while he's at home that he realizes the importance in a peasant village of the peasantry. And this is what would always set Mao apart from the leadership in either the Communist Party or the Kuomintang Chiang Kai-shek's group. They were counting on the urban proletariat to move the revolution, but Mao always placed his fortunes first and foremost upon the peasantry. Well, it wasn't just Mao Zedong. There's the Long March that eventually gets Mao Zedong out of the range, you could say, of the Kuomintang. They are briefly in Changsha. The Civil War comes, the war with Japan comes. Eventually, Mao Zedong and the communists succeed not only in finishing the war of resistance with Japan, they succeed in defeating the Kuomintang, and the rest of the story you're familiar with. On October the 1st, 1949, the People's Republic of China is created in Beijing, and Mao Zedong is made chairman of the republic. That, in 2 minutes, is Mao's history. Well, having said that, Mao was not the first person to appreciate the importance for science and technology in the new China. This actually goes back to such famous figures as Chen Duxiu in the 1920s. Following the War of Resistance with Japan, he actually, he was one of the intellectuals in China who saw also the strong links between science and the development of technology that would help to change China from a feudal country into a communist state. And as Chen Duxiu, a graduate of Hangzhou University, also studied in Japan, a founder of New Youth, one of the great revolutionary publications in China in the early 20th century. He became a dean of Peking University and co-founder of the Chinese Communist Party, as he writes in 1920. The political evolution goes from feudalism to republicanism and from republicanism to communism. I've said that the Chinese Republic has failed and that feudalism has been reborn, but I hope that soon the feudal forces will be wiped out. I'm convinced that the creation of a proletarian state is the most urgent revolution in China. He goes on to say that republican government and politics and science in the domain of ideas, these seem to me the two treasures of modern civilization. And he was not alone in feeling this way. I'm going to simply abandon my notes here because I have 15 minutes to probably try and tell you maybe 45 minutes worth of material that I have. So I'm going to simply summarize what you can read in greater detail. Any of you who would wish to have a copy of this, I'll be happy to send you the details. But going through all of this, I can see, is not going to really be possible. So I'll give you the impressionistic version of what I'm interested in conveying this evening, and all the details, which I think are important to really explain why the events took place the way they did. You can read at your leisure another time. Simply email me. I'm very Googleable. So if you simply email me, or you can ask the administrators here at the Athenaeum, and they can give you my email address. I'll send you the complete version of this lecture. But Guo Mo was another of the great figures of the early movement in China to bring science and technology into the fore. But he also appreciated the role that Marx would play in this process. And then Mao Zedong himself. Where do correct ideas come from? This is something worth emphasizing because, as he says, do they drop from the skies? No. Are they innate in the mind? No. They come from social practice and from practice alone. It's man's social being that determines his thinking. Once the correct ideas and characters of the advanced class are grasped by the masses, these ideas turn into a material force which changes society and changes the world. Furthermore, the one and only purpose of the proletariat is knowing the world is to change it. Often, correct knowledge can be arrived at only after many repetitions of the process leading from matter to consciousness and then back to matter, that is, leading from practice to knowledge, then back to practice. You can see the Hegelian dialectic going back and forth here. Such is the Marxist theory of knowledge, the dialectical materialist theory of knowledge. Wu Zhihui talks about this as well, another of these early intellectual figures in the transformation of modern China. He's interested in how the steam engine and petroleum-driven engines can play a role in doing this. And I should tell you that all these people were either in part trained in the West, some of them at Cornell University, where the New Science magazine was established, the Science Society of China was established. These were all people who were really interested in how science and technology would play formative roles in creating modern China. And then Mao Zedong. If a man wants to succeed in his work, in other words, to achieve the anticipated results, he must train his thought to correspond with the laws governing the objective external world. If they don't correspond, he'll fail in practice. So this is where Mao becomes interested in science, the way in which you could say Marx had become interested as well. Dialectical materialism, Mao wrote in a lecture of 1938, is the worldview of the proletariat. The proletariat, which has been given the task of history of eliminating classes, utilizes dialectical materialism as a spiritual weapon. This word comes up again and again. Marxist philosophy holds that the unity of the opposites is the fundamental law of the universe. And he takes on Newtonian mechanics in an analysis of exactly how you could come to understand this. But he also talks about the unity of opposites in this discussion. Of particular note, he says, is Newtonian mechanics, which treats space and time as unrelated and static insubstantial entities, and which situates matter within this insubstantial context. These relative conceptions, he says, in their development move towards absolute truth and approach nearer and nearer to it, in quoting Lenin. But what I want to get to is not what he has to say about this in On Motion. He develops this in the context of chemistry and in physics. But here's what he says about mathematics. In mathematics, any number contains internal contradictoriness and can become a positive or a negative number, a whole number or a fraction. Positive and negative, whole number and fraction constitute the movement of contradictions within mathematics. Now, I don't know where Marx got his where Mao got his mathematics from, but the view was certainly consistent with his philosophy. Now, how did we come to get two translations of the mathematical manuscripts of Karl Marx, and how did this fit into the overall picture of what Marxists wanted to see happen in China and people like Mao who were applying these ideas in their political philosophy, but also in social reform as well? In 1975, a group was working in Shanghai at Fudan University. Remember, the mathematical manuscripts of Marx had just been published in the dual German and Russian edition a couple of years previously. So these were very, very well clued in people as to the status of Marxist scholarship with respect to the mathematical manuscripts. And they produce a series of articles that reproduce various parts of the mathematical manuscripts of Karl Marx, beginning with an introduction that is a remark on the translation itself. The Acta Mathematica Sinica, meanwhile, is publishing a version of these manuscripts that was being done by another group, apparently without the knowledge that somebody else was working as a group in Shanghai, this group in Beijing. And they too were interested in producing the mathematical manuscripts in a Chinese version. And in an explanation for printing excerpts from the mathematical manuscripts, they write as follows. To promote the great campaign criticizing Lin Biao and Confucius, the mathematical manuscripts of Karl Marx, who inspired the proletarian revolution, were translated and edited by the Mathematical Manuscript Study Group of Beijing University and published by the People's Press. This is a great event in our ideological battlefield. Again, that word again. Lenin pointed out that with material dialectics to improve essentially the entire political economy, using dialectical materialism to elucidate history, natural science, philosophy, and the policies and strategies of the working class is the most important thing of concern to Marx and Engels, whereby they made their most important and novel contributions and brilliantly took a great step in the revolutionary intellectual history. These are mathematicians writing, but they're writing knowing that they've got to put their work into the larger context of the Cultural Revolution. The edition in Chinese was finally put out in a definitive edition in 1975. I was very lucky when I was in Huahat. Professor Li Di had an extra copy, and he gave me one of his copies and said, here, you might find this interesting to read, and in fact, I did. It included facsimiles of Marx's original manuscript pages, and almost immediately, within an issue of the various journals that were publishing the excerpts from the mathematical manuscripts, people started writing in with their own versions of how these mathematical manuscripts could be used to sharpen the understanding of mathematics. He Fang wrote from Beijing Middle School number 144, talking about how should the concept of limit be understood. Fu Shitao in Shanghai Factory number 5703 wrote, trying to say something concerning my feelings about improving teaching of the calculus using dialectics. Zheng Lixing in the Fujian Electrical Engineering School in Fuzhou writes an article about the differential is comparable to zero. And of course, this is talking about the differential as both zero and non-zero in those same Hegelian terms that we've already noted. The Dialectics of Nature went on to publish no fewer than half a dozen brief excerpts, as well as the entire articles that they'd received, drawing on the inspiration that publication of the mathematical manuscripts of Karl Marx had engendered in the larger Chinese community. Zhi Zhou wrote an article, interestingly enough, How to Understand Derivatives, in the Journal of Beijing Normal University. He was not simply a factory worker or a high school student, but now mathematicians, serious mathematicians, were making their contributions. And he has some very interesting things to write about. Newton and Leibniz's contributions to the calculus are great pioneering works in the development of mathematics, but due to the constraints of metaphysical ideology, their works could not avoid being colored by mysticism. This is the critique that will come up again and again. The mathematics might be okay, it requires the correct Marxist foundation. If we can get the foundation right, then we can do the mathematics without worrying about it. Zhi Zhou goes on. Our revolutionary leader, Marx, because of his deep grasp of the method of dialectical materialism, thus focused on the idea of the derivative and advanced a series of brilliant dialectical thoughts, even though over the past 200 years mathematicians have been working but have not yet been able to make a great contribution. Remember, Marx had never read Cauchy, so he was oblivious of what Weierstrass of the 19th century had accomplished, and that may be in part why this particular view appears. Marx's mathematical manuscripts are one part of a brilliant, monumental mathematical work and are a precious scientific legacy Marx has left to us. But it's also a part of his philosophy which uses the methods of dialectics as a model for studying mathematics. Teaching and studying the mathematical manuscripts is necessary for today's revolution in education and is needed in the battle to conquer mathematics. This was the other way in which Marx's mathematical manuscripts could be used by mathematicians to justify their contribution to the Cultural Revolution. The idea is that everything in society was undergoing a self-criticism, and mathematicians could use the Marxist mathematical papers to undertake their own criticism of mathematics, create a new foundation for the calculus, a new way of teaching it that would be in concert with Marxist ideology. And this was basically the approach they took. As Zhi Zhou says, scientists and especially mathematicians, from the study and research of the mathematical manuscripts, have a powerful ideological weapon to transform directly the old mathematical system and to reform the study and teaching of mathematics. Well, others followed in suit. Wu Xiehe and Zhang Huaxia of Central China Workers' College produce a paper understanding calculus from the point of view of the paradoxes of motion. They want to know, how can a moving point be in one place and not be in that same place at the same time? Applying these same Hegelian arguments, but this time trying to fashion a way in which you could actually teach the calculus based upon these ideas. They go on to say, 100 years ago, the great revolutionary teacher Marx wrote his mathematical manuscripts, and although in the course of these 100 years mathematics has undergone tremendous development, Marx's mathematical manuscripts nevertheless shine with a brilliant radiance. Marx and his mathematical manuscripts use the special materialist dialectics of Marxism to criticize every shade of idealistic metaphysics, tearing the mysterious veil from the deceptive derivatives and differentials and bringing to light their true essence, thereby setting a brilliant example for us. So we can criticize the ideology, give it a proper Marxist founding, and then we can do our mathematics. I'm going to skip a number of these which simply repeat the same ideas, but there are a lot of people writing about these attempts to put mathematics in China on a new foundation, to reform teaching in China using the ideas of Marx from the mathematical manuscripts. It was in 1975, in an issue of Understanding and Practice of Mathematics, that two aphorisms from the sayings of Chairman Mao were quoted. From a certain point of view, the most talented and able soldier is one who has had the most practical experience, and our improvement is improvement on the basis of popularization. Our popularization is popularization under the guidance of improvement. Now, this appears in a mathematical journal, but it was again attempting to use the slogans of Chairman Mao and the ideas of Marxism to again popularize scientific ideas, and many of the people who were mathematicians before the Cultural Revolution went into factories like Wu Wenjun to teach the workers mathematics that they could use to improve productivity, improve output. I won't say more about the ways in which this was done, but to say that 1976 was another fateful year, a turning point for China. It was a year of the dragon. January the 8th, Premier Zhou Enlai dies. July 28th, there's the earthquake in Tangshan. 655,000 people were killed. And then on September the 9th, Mao Zedong dies. And here's the title page of the journal, Understanding and Practice of Mathematics. I mean, journals across China had the picture of Mao Zedong and exactly the same slogan across the top: eternal glory to the mighty leader and teacher, Chairman Mao Zedong. Inside it explained they're going to build a monument to Mao Zedong in Beijing, and they're going to publish his collected works. And the first article in that issue of the journal, studying different world outlooks from two different kinds of mathematical approaches, using, on the left, D'Alembert's mathematics, and on the right, Karl Marx's. And you can imagine which one is going to receive the preponderance of approbation in this particular article. But it was, again, using the Marxist mathematical papers to follow the Marxist Maoist line in how mathematics could be used to reform mathematics, to reform teaching. And then comes the most interesting article from my point of view, one continuing to use Marxism to study nonstandard analysis. It doesn't go into a great detail about nonstandard analysis, but it says that this is a means of rehabilitating the infinitesimal. And Karl Marx had said that the proper foundations for the calculus ought to be the infinitesimal, not the limit. It should go back to rehabilitate the ideas that Newton and Leibniz had used in a rather obscure way, but now Abraham Robinson gave mathematicians in China a sound foundation on which to introduce the concept of the infinitesimal to Chinese mathematics. And that's what this article argues should be done. I'm not going to go into these further criticisms that appeared in that same journal after the death of Mao Zedong, because I want to get to one last point here. I've never given this lecture in quite this form before, so you can see I came over-prepared. Okay, but here's the conclusion that one of these last papers in that journal made. Our critical analysis of modern mathematics amalgamates two positive results. Now updating that of Cauchy, whose theory of limits provides a foundation for standard analysis, and that of Leibniz in terms of non-standard analysis due to the Abraham Robinson. Their dialectical synthesis results in the sharpest ideological weapon. So now they found a way to take the best of modern mathematics in the Cauchy approach to providing a solid foundation for the calculus, and then incorporating the latest work of Abraham Robinson, the foundations from non-standard analysis. And then there's one last paper that, if we had time and we were philosophers of mathematics interested in how the Chinese justified the foundations of non-standard analysis, this article is particularly interesting. It's obviously written by a mathematician and a very savvy philosopher who understands non-standard analysis in its details, because he talks about how the fact that what Abraham Robinson has accomplished can be extremely useful in China, but you've got to get rid of his idealistic metaphysics. It's the conception of the infinitesimal, as Robinson says, that has no foundation in physical reality. It's simply an axiomatically introduced concept that is anathema to this approach of Marxist ideology. And yet this argument is we forget about the idealism of Robinson will provide our own foundation for infinitesimal analysis, and then everything will be okay. And this is what he says at the end. In evaluating non-standard analysis, we should acknowledge Robinson's mathematical work, but must seriously criticize his philosophy, which is a serious and important task facing both scholars of mathematics and philosophy. And so the final point I want to make in conclusion is that within 2 years of the Cultural Revolution, as my friend Liu Dun at the Institute for History of the Exact Sciences said, the only real difference between you and me, Joe, is that I spent 10 years during the Cultural Revolution as a cowboy in Inner Mongolia. But he came back from that revolutionary experience, and within 2 years he was at the Institute for Natural Sciences in Beijing studying to become an historian of mathematics. And within 2 years of the end of the Cultural Revolution, the first China Symposium on non-standard analysis is being held in Xinjiang, and you can see how many people are there. Serious mathematicians ready to get back to work within 2 years of the Cultural Revolution. I find this extraordinary in the testimony that it gives to the mathematicians who, despite the fact that they may have been sent to the countryside or sent to work in factories, their mathematics was never forgotten. They somehow managed to find time at home, at night, on weekends, to continue as best they could their work. And as soon as the revolution was over, they were back in their universities. They were bringing a new group of students into those colleges and universities. They were doing their own research, and they were bringing modern mathematics into what they hoped would soon be a modern China. I first went in 1987. I was living on a little hutong, as I told you, for 3 months in Beijing. Then I traveled all over China. The China that I saw then, riding on my bicycle, is a Beijing I could not ride a bicycle in today. If you've been to Shanghai and you've seen Putong, it looks like something out of a science fiction novel. What China has managed to do in the past 30 or 40 years, training world-class mathematicians, the International Congress of Mathematics was held not many years ago there, is truly, I think, a credit to the resilience of mathematics and those who practice it. And that's the word that I want to leave you with this evening. Pardon me for running over a little more than I should have with my time, but I'm prepared to answer questions as best I can. Thank you.
If there are any questions, please raise your hand and Michael or I will come to you with the microphone.
In addition to mathematical manuscripts, Marx used mathematics in his economic theories. Especially the one that I'm thinking of is Das Kapital Volume 3, where he attempted to solve the problem of transformation. He wanted to transform the labor values into prices. Now, that was received with controversy. I was wondering what you think about the level of mathematics he used there, using today's, thinking about today's knowledge.
Mm-hmm. I wish I could tell you I was an expert on the application of mathematics in Marx's economic theory, but I really have to plead that I have not studied that aspect of what Marx was doing. I can only tell you that in reevaluating the application of Marx's use of mathematics by mathematicians, even in China, they've now concluded that it really wasn't as stellar a contribution as it was made out to be during the Cultural Revolution. I'm interested in what Marx had to say about mathematics in terms of how he was able to philosophically find a justification for it in the context in which he wanted to apply it. And Engels did virtually the same thing. I mean, these were both, in a way, self-taught men when it came to what they knew about mathematics. As I said, all Marx knew of his mathematics was what he had been able to read in textbooks that he could find in the British Library. And I've always wondered, what would his mathematics have looked like and what would his arguments have been like had he read Cauchy or even Lagrange? I mean, these would be questions Judy might be able to tell us something more about. But it's really that aspect of Marx's mathematics that I've looked at, and I have to just be honest and say I have not looked at how this all played itself out on the mathematical side of Marx's work.
He mentioned living in Italy and obviously China for part of your life, and I was just wondering actually, I don't know if you're fluent in either of those languages, but I'm assuming you are. Are you fluent in Italian and Chinese?
I can speak Italian and Chinese. My basic goal is to, if you can, order a sandwich and find your way home, you're on the right track. I think it's almost impossible to learn a foreign language without living in the country where it's being spoken. And I have lived for a considerable amount of time in both Italy and in China. People say, where did I learn to speak Chinese? My answer is, I'm still learning to speak Chinese. I don't think that if you were not born to Chinese, it's really possible to learn to speak it like a native. I think you will always have a very clear accent. But I was very pleased when I went to Taiwan a number of years ago, and there was a canteen at the Academia Sinica, which is in Nangang in Taipei. And I went and I said, I'd like to buy a can of Coca-Cola. You have to buy Coca-Cola. I said, and they said, what? And that's a kind of Beijing way of saying it. And I was very pleased that they knew I was from Beijing. They said, well, we don't sell that in Taiwan. And I had to say it without the R before they would sell me the ticket that would get me my can of Coca-Cola. But I think it's very difficult to claim fluency in a language like Chinese unless you were actually born to it. So I do not claim to be fluent in Chinese, but as I add, I am not trying to translate Tang Dynasty poetry or Warring States political history. The work that I do is on ancient Chinese mathematics primarily, and these more contemporary kinds of contexts within which modern mathematics is being done in China. So I have a very set vocabulary that I need to be familiar with, and the grammar for Chinese is not as complicated as it might be if you were trying to learn German, for example. And my German is a language that I came to speak fairly well after spending a year in Berlin working on my doctoral thesis on Georg Cantor in the late 60s. And I spent a lot of time in China, and my Chinese, I would like to think, gets better and better, but I would never claim that I have fluency or mastery of the language. But for the purposes that I need, ancient Chinese and modern mathematics, I think I have the basics that make it fairly easy to work with. And I don't work alone. I also work with a team of people in Beijing, Guo Shuchun and Cao Dahai are two highly trained specialists in ancient Chinese mathematics, Warring States pre-Qin period, which is primarily what we work on. And then people like Liu Dun working on modern mathematics. And I never publish anything without passing it by them first to see what they think. And if they say, okay, this looks all right to us, then I'm pretty confident that I can go ahead and publish it and not run into too much trouble. But if they say, no, you got this all wrong. One of the things I didn't happen to mention, but there are a number of people's names who came up in these publications. They're pseudonyms, because during the Cultural Revolution, people didn't necessarily want to publish under their own name. And so you'll see words like mathematician on the left, for example, Shuzuo, and maybe that's a pseudonym for somebody that's trying to tell you that, well, they're a mathematician, they're left-leaning, but that's not their real name. So I would never have known this if one of my colleagues in Beijing hadn't pointed this out to me. I was probably, well, maybe that's their name. It looks a little strange, but that is the sort of thing that a native will tell you, and that's the sort of thing that is very helpful to me. So I fully acknowledge the collaboration that I have with my colleagues in China.
Just a quick follow-up to that. I was just wondering if, like in college and graduate school, you ever thought that your pursuit of the history of mathematics and sciences and that field would ever lead to you learning 2.5 languages, it sounds like, or more?
And actually, it didn't. As I said, the turning points in your life come when you least expect them. And when I went to China, I had a 1-week training course in Bethesda, Maryland, that the American Academy of Sciences and the NSA give you to get you ready to go. And so I knew basically what to expect in terms of housing and lodging and everything else. But I went, if there'd been a Lonely Planet guide to China, I would have taken it with me. But there was nothing like that. So I arrived in Beijing literally with what I call my Xiaohongshu, my little red book. But this was the Oxford Chinese English Dictionary. And I used that, and I had a magnifying glass, because these dictionaries are very tiny, and I find them very hard to read. And I sometimes try to find a character, and I couldn't find it. And I was always very pleased when the Y-Ban in our unit, my Danwei, the group I was working with in Beijing, the Y-Ban is the person who's looking after foreigners. And she was also my Chinese tutor. And so she said to me, she said, if you have any trouble with your Chinese, just let me know. So I'd be reading along and I'd have a character. I couldn't find it in the dictionary. So I'd give it to her and I said, can you find this word in the dictionary? And I was always grateful when she couldn't find it either. No, I can't find it. And then you see Chinese students who come here and they've been here for 2 or 3 years and they begin to, you see them doing this and they're trying to remember, how do you write that character? I mean, Chinese is a very memory-intensive language to use. And if you don't use it every day and all the time, it's very likely to start to fade. And when this happens to my Chinese friends who've been in the States for 15, 20 years, again, I feel vindicated. I shouldn't feel so bad if I don't, have all this at my fingertips all the time. But no, I didn't expect that. And the other thing I didn't expect when I first got to Beijing, the Y band said, now you're going to need a bicycle. So she gave me a bicycle. And she said, I'll teach you how to ride it. I said, I know how to ride a bicycle. She said, no, not in Beijing. So we're on the bicycle, we're going down the Hutong, and of course there's nobody else in the Hutong, so that's fine. And then we get out onto the main street, and this street was one that wound down into Wangfujing. And if you know Beijing, Wangfujing is like the Fifth Avenue of Beijing. And there are just thousands of bicycles. And what's really extraordinary is that all these bicycles are going at exactly the same speed. Now here there'd be somebody going 10 times faster than everybody else, weaving in and out, but no, everybody's just moving like a very calm, tranquil sea in the same direction. So it's like when I'm driving on the freeways here, I only drive when I'm in California, and it terrifies me. But I'm on a freeway, I'm fine if I'm just in the middle lane going straight ahead, but then if I have to turn left or turn right to get on or off a freeway, that's when I have trouble. So I'm on my bicycle in Beijing, and we're going along, and I said, well, this is fine, but we've got to turn right up here. How do I do that? There's all coming from behind and in front of me. She said, don't worry. You just ring this little bell, and you say 3 words. Well, maybe it's 5. But anyway, she said, you just say after me, as loud as you can, 小心点儿外国人, and turn. So I do that. I turn. The seas part like the Red Sea. No problem. Oh, I'm getting the hang of this. So I have to go left. Go, 小心点儿外国人, turn this way. Parts the Only later did I discover that what I was saying is, watch out, foreigner. Everybody gets out of the way. So what I didn't tell the group of students here, but what I tell my own students, and I tell anyone who listen religiously, after your college experience here or your graduate work, wherever you may go on, if you're going to do a PhD or further graduate professional work, medical school, law school, whatever, the best education is travel. You cannot get a better education just by going to other countries and seeing how other people do things, and very soon you'll find maybe the way you've been doing things all along isn't the best way. Maybe there are other ways you could think about doing things. And fortunately, I love to eat strange and exotic things. And so getting to China for me was just a wonderful experience, things that I'd never seen and experienced before. And people were always wanting to play tricks on you. So they say, is there anything you don't like to eat? And then when you say, oh no, I like to eat everything, there's one restaurant in Beijing that's famous for serving nothing but bugs. So my colleagues took me to that restaurant when I was first in Beijing, just waiting to see the expression on my face. My philosophy is if everybody around you is eating it and they seem to think it's pretty good, there's no reason why you shouldn't at least give it a try. So, I wouldn't go back and order grasshoppers again, but you can get through it. And if you're ever in a desert and the locusts come and there's nothing else to eat, at least there's a good source of protein and it won't kill you. So that's my advice when it comes to travel and education.
Could you tell us a little bit more what Marx actually wrote in terms of mathematics?
Mm-hmm.
You said 900 pages or something that he wrote.
I'm not sure it's 900 pages, but...
I mean, there's a book that's been published. It's Karl Marx's, mathematics. Did he talk about solving some equations? Did you talk about series? I mean, you mentioned he didn't know about Cauchy's work, but did he have anything else from calculus there?
Well, what interested me most in looking at the mathematical manuscripts of Marx, and since he hadn't really read much in the way of mathematics or the calculus beyond the 17th and 18th century textbooks, it is largely about just the techniques of how you can differentiate or integrate and how you might be able to apply that to a particular problem. So that aspect of what he was writing about is pretty much out of the textbooks that he was looking at. What interested me was when he became interested in historically analyzing what had happened in mathematics. So he has a very interesting development where he's looking at the Newtonian calculus versus the Leibnizian calculus, and he looks at these foundational debates between Berkeley and Uintendit, and he tries to see this in the context of the Hegelian analysis, as I mentioned earlier, of thesis, antithesis, synthesis. So he's trying to find a way that, and he knows that there are questions about why does the calculus work? I mean, everybody in the 18th century was trying to figure out, if there are all these problems and it's so contradictory, then why does it seem to work so well? And there was one whole theory that believed that, well, it's a cancellation of errors. You know, if you have an error on this side, then it cancels by an error on the other side. And there were people that wrote about this. But Marx was trying to figure out, was there some dialectical reason that he could use to justify the faith that he put in the calculus, that it worked, but he wasn't quite sure why. And so he tries to give it a Hegelian foundation and feels that that's sufficient. But beyond that, I really can't tell you more of the details.
Hi. Thank you for your lecture. It was very interesting. So I have a question. So to which extent, so in China, this entire ideological program, presumably based on Marxism and mathematics, to which extent was this actually implemented in practice? Now, the reason I'm asking is, so I grew up in Soviet Russia, and while the original collection, as you pointed out, comes from Russia, perhaps in Russia it existed in theory. I have never seen it implemented in practice in mathematical education. So has this actually been done in China?
Well, let me separate this in two ways. And I think it's fair to say that in China, during the Cultural Revolution, if you were a mathematician and if you wanted to be able to do your mathematics, this provided you with a justification for doing mathematics and, in fact, maybe legitimately trying to find better foundations, better ways to do teaching. So it offered them that justification. This is during the Cultural Revolution. Within 2 years of the Cultural Revolutions being over, however, you've seen what mathematicians were beginning to do. And I don't know of any evidence that this program continued much beyond that. Now, there were people in institutes, my own institute 10 years after the Cultural Revolution, that were still having their indoctrination meetings. And they would have to go and sit there, and there would be somebody reading, and they would all be reading the newspaper, but they had to go. But I don't know that they actually incorporated it into what they were doing in textbook writing, for example, and things like that. It may be similar to what I remember when I was in Berlin in the late 1960s, and the Berlin Wall was still up, and I had to live in West Berlin, but I would go across the Berlin Wall every day into East Berlin because I was working at the Akademie der Wissenschaften, which was on Unter den Linden in the east. And that's where the mathematical archive was. And all the papers I wanted to see of Weierstrass and other mathematicians were there. So I would go back and forth. You would see the works that the historians of mathematics working in East Germany would write. And they would all begin with a preface that would talk about Marx and Lenin and all the things that the dialectic had to do with the books that they were writing. Then you'd read the book, and there was no further mention of Marx or Lenin. It was all part of the window dressing that made it possible for them to do what they did. And if they didn't do that, they would never get published. So my sense is that during the Cultural Revolution, of course people did this because it was a means to allow them to do what they really wanted to do. And if they didn't do it, they couldn't. And then you have people like Hua Luogung or Wu Wenjun, prominent mathematicians who did go into factories and tried to use operations research and tried to find ways that they could optimize production with the most unproductive of materials, how could they still get the best results? I mean, they really tried to teach the workers how they could use this mathematics to improve what the factories and the workers were supposed to be doing. And it's always seemed to me that one of the legacies of the Cultural Revolution that is often forgotten is that it did tend to create in China a very different society, because the intellectuals were sent out to live with the peasants, and the peasantry learned more about what it was like in the cities. And there was, I think, a kind of at least appreciation for each other that hadn't been there before. And my colleague Liu Dun, the cowboy for 10 years during the Cultural Revolution, he was sent out to Inner Mongolia. He and his wife, the woman that he met, and they fell in love, and they had their first child there, their only child, Xin Yi, in Inner Mongolia. They were hoeing potatoes for 6 months. And then, as Liu Dun said to me, these people aren't stupid. They came to us and said, you're terrible at this. You don't know how to hoe and plant and harvest, but you could set up a school. You could set up a one-room schoolhouse. You could teach our children. So Liu Dun and his wife set up a school, and they taught their children for the 10 years or so that they were there during the Cultural Revolution. They then went back to Beijing. 15 years later, I'm in Beijing. Their young son, Xin Yi, is grown up, 15 years. They say, our son has no idea what the Cultural Revolution was like. We're going back to Inner Mongolia to spend a week, going back to our little village. Would you like to come with us? I said, you have to ask, when are we leaving? So I went with them and spent a week in Inner Mongolia in the grasslands, going back to their little village, and it was extraordinary. And all the people in the village came running out and remembered them, and were so grateful that they had been there and taught their children, and their children were now in the cities doing their things, but the parents in that generation were still there. It was just extraordinary, and I think the Cultural Revolution is sometimes seen as an entirely negative experience, and for many people it was, and what the Red Guards did to many people, particularly if they were very educated and privileged and maybe had abused that, suffered tremendously. And people have written books about that, which anyone can read. But for many people, I think it was an extraordinary experience in China. And the barefoot doctors movement, all of those things, did things in China that wouldn't have happened otherwise. So I think it's something that one should keep in mind.
We'll have time for one more question.
Well, if there are no further questions, let me apologize for having run over my allotted time. But I want to really thank everyone for being here this evening and for the invitation to come to Claremont, come back. This is my homecoming, in a way, my reunion, the 50-year reunion I couldn't make last spring. Well, I'm getting it now, and I'm really enjoying it, and I'm appreciating very much being here, particularly meeting the students this evening at our table. I wish that conversation could have gone on for another couple of hours. And so, again, thank you for having invited me, and it's been a real pleasure for me to be here this evening with you. Thank you.